Hi, my name's Tom, and today I'm going to be talking to you about how we can use some of the Springboard Key Stage 3 science resources for teaching using an interactive whiteboard or projecting onto a whiteboard or any similar such teaching methods. We're going to be looking at the Year 7 physics topic of speed, and particularly one of the subtopics of distance time graphs. To begin my preparation for this lesson, I would have a look at the student knowledge book to ascertain all of the knowledge that I want students to have by the end of this topic and what particularly I'm going to be focusing my explanations on today. So these are the early parts on speed, which comes before the lesson. So I'd want to be sure that students understood all of these things before I went into my explanation that I'm going to deliver. And looking at this Part P 2.2 distance time graphs, these are the things that I want my students to be able to understand over the course of the few chunks that will form part of this lesson or series of lessons, depending on how the pacing goes. So I'd make sure I'm familiar with this to get my wordings right. I would also make sure I'd refer to the working scientifically section of the knowledge book, as some of that will be relevant, particularly the part on graphs, to ensure that the way in which I deliver my explanation is consistent with what has previously been taught about graphs, how to read scales and things like this. So all of that knowledge being made clear within the knowledge book is really helpful in me building my explanation as well. The next thing I would do is have a look through the teacher book to have a look at the exact suggestion of how I might explain the particular thing that I'm looking at. So today we're going to be looking at how to read values on a distance time graph. I think this shows off some of the really excellent features because it shows how adaptable the resources can be, and really shows off how you can use it with an interactive whiteboard because of the annotating on the screen. So what I'll do in a second is I'll deliver the explanation that follows this roughly, so you can see what it would look like.
When beginning this explanation of how to read values from a distance time graph, I'd put up the graph and ask students to take a moment to look at the graph and pay attention to any of the relevant features. This just gives them a second to orient themselves in a way with the information we're about to present. After they've done that, I would then ask them some basic questions to make sure that they understand how to read values from a graph. So for instance, I might ask them, what distance was the object at 5 seconds? Personally, I'd ask them to answer this on a mini whiteboard so I could see all of their responses, and hopefully they'd be able to give me the answer of 5 meters. Because there's a correspondence there of 5 seconds, 5 meters, I'd probably ask a second one to ensure that they weren't under the misunderstanding that the number of seconds matches the number of meters. And once I was happy that they could read values from a graph, I'd then move into my explanation. And my explanation would go something like this. So we can see here we've got a distance time graph, as we've seen previously. We've got distance on the y-axis measured in meters. We've got time on the x-axis measured in seconds. And what we can see here is there's some data on the graph. This shows one particular journey. We can see here, we've got the start point of the journey. And this journey then progresses over time to this point here, which is our end point. Now we can use the values on a distance time graph to tell us something about this journey. So to begin with, we can simply look and say, what time did the journey start? To do that, I look at this start point and I will read down to the x-axis and find that the journey started at 1 second. I can then find the time at which the journey ended. So I find the end point of the line and read down to the x-axis to find the journey ended at 7 seconds. I can then from this calculate the journey time. Now the journey time here is the difference between the end time and the start time. So in our case, this journey time is 7 seconds minus 1 second, which is 6 seconds. The second thing that I can find from our distance time graph is how far this object has traveled. I'm going to follow a very similar method to what I did with time, but now I'm going to be using the y-axis. I'm going to start by looking at the start point of my line and looking at how far the object was when it started moving, which is 3 meters. I can then look at the end point of the line and read across to the y-axis and find that it ended at a distance of 6 meters. And much like I did with the journey time, I can find the journey distance by subtracting the end distance from the start distance, which is 6 meters minus 3 meters, which is 3 meters. What I would then do is I would put up a second example for students to do at this point. Depending on the class, I might go through this personally with them and go through that whole process again. Or I might start to use this as a mini check for understanding, where we're doing this almost in combination, where I ask a few students to tell me what they would do next. After that, I would then do a proper check for understanding, which is a different graph entirely, where I'd get them to start to answer on a mini whiteboard. At what time did this journey start, or what time did this journey end? How long was the journey for? And make sure I've tested each of the individual components that we've just gone through. And there are a few different graphs that we can do check for understandings with. Equally, we've made sure that there are blanks in there, so that if you want to add in your own examples, or you just feel like your class need another couple of examples, you have that option to adapt the resources for the class that you have in front of you. And just note that as part of this explanation, we are delivering just one tiny component of the wider composite that is understanding how to calculate speed from a distance time graph. We're not trying to do that in this moment. We're just trying to make sure that we can find the distance and the time for a particular journey, and then we're going to use their previous skills of calculating speed, which they'll have done extensively in the previous part, and then use the every method to calculate speed as they have done already. So we're trying to make sure that the skills students are developing are linked together.
Once I'm satisfied with the check for understanding that the class are doing things correctly, I would then choose some of the questions from the practice book that I want them to do. The number of questions that I ask them to do will vary dependent on the class, but I would have a look through beforehand and ensure that I've picked the right ones for the students in front of me. And you can see there's a wide variety of questions that follow a really similar format to the way in which I delivered my explanation and the way in which I delivered the check for understanding. So overall, that's how I'd be using these resources to teach this one tiny chunk about how to read values from a distance time graph. Hope you found that useful. Thank you very much.